Hello there, it's Ashraf here, and today I want us to look at how we can work with a framework of this format. This is what we call a framework that is overhung. We call it overhung because the reactions are no longer at the extreme ends of the framework, but rather in the middle somewhere there. So we treat this differently when it comes to the vector diagram part, and that's my interest for tonight. So let us see how to go about that. So before anything, you have to determine a scale, and according to this, I'm going to say that I want to represent 5 newtons with 20 millimeters. So from this, I can derive a scale which is going to say that 1 newton is actually equal to 4 millimeters. So this is my scale. And then for the meters, I'm going to say that I want to represent the 12 meters with exactly 60 millimeters. So when I divide through here, you can see that 1 meter is actually going to be equal to, so 1 meter is going to be equal to 5 millimeters. Perfect. Now that we have a scale, we can draw the accurate figure there. So I'm going to start off by drawing a horizontal line. Onto this horizontal line, without wasting time, I'm going to put a vertical line there. Now, as you can see, the distance is 12, and they're telling us the distance from here, up to here, up to here, up to here. These distances are all equal. So this is 12 divided by 4, which gives me 3. So 3 meters, according to this, would be 15 millimeters. So I'm going to measure 15, 15, 15, and finally 15. And right there, I can slide. I know where my framework stops. So I'm going to put a 30 that other side, and this right here is a 30. And I also put a 30 this other side. I can outline this. The framework is small because I'm dealing with space here, but please bear. So that is what I have. Then there is a member here, a member here, and then according to this member here meets this at 90 degrees. This is what I'm saying. This member meets this one at 90 degrees. So I'm also going to do exactly that. So this is how I place my set square. This is 90. So slide 90 to this point. Do the same thing this other side. Slide 90 right here. Perfect, and that's our framework. So I'm going to attach the forces that we have in here. Perfect. So we have a force here. Force, 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 force. Then reactions here and here. So RL, RR, 3 newtons, 2 newtons, 5 newtons, 1 newton, and 4 newtons. So we have a complete space diagram. So name it. So this right here is a space diagram. Perfect. Now that we have a space diagram, we can draw a polar diagram. So small distance away from this, draw a vertical line, and onto this vertical line, we're going to put all the forces. So that requires us to name. And to name this, since we have a force here, I'm going to start from out here. So A, B, C, D, E, F. Now remember we said every time we said this for the beams, but it applies even here. Every time we have a letter outside, this letter is actually for the space below. So for this space from this point up to the reaction don't get confused by this line, but up to where the reaction is, this whole space is for B. Same applies for F. This F down here, from this point up to where the reaction is, that whole space is for F. So F, this will be G. I can also name inside, this is H, then J, I'm going to skip I, then K, L, and M. I don't like I. Perfect. Now I'm going to draw a polar diagram. So 3 newtons according to my scale will become 3 times 4, which is 12. So come right here and mark off 12. Now 12, this is A, B. Then BC is 2. 2 times 4 is 8. So 8 right here. C. Then 5 is 20. D. Then DE is 1, and that would be 4. So E, and finally F. So F is 4. 4 times 4, that is 16. Right here. So choose a point somewhere here. Then join all these to that point, which we usually call knot. I can now outline this, calling this knot. And remember, we said we are sliding a knot into the space of A. So get your A knot and slide it into the space of A. And we say the space of A is running from this point up to the reaction. So this is the space of A right there. From this force up to the reaction, that is the space of A. Then come to B. B knot, we are putting it into the space of B. So the space of B is starting from here up to this force, so that would mean I'm starting there and I'm ending right there. Then C knot. D knot. Then E knot. So E knot, as you can see from here up to here. And finally F knot. The space of F runs from the reaction up to that force. So from here up to where the reaction is, which is there. Make sure you don't get confused. So join the last point to the first point with a line, and then slide this back to your polar. And by doing this, ladies and gentlemen, we can determine the reaction. So determine RL and also determine RR. I'm leaving that for you. Let me jump right into drawing the vector diagram. So we can name these So to draw a vector diagram, we are going to need a fresh polar diagram. So I'll slide a vertical line a small distance away from this one and put it right here. So come up here, start with AB. AB is 3 newtons. So I'll measure 3 times 4, that is 12. So measure 12. So A, B, or you can simply transfer this one onto this point. So BC is 2 times 4, that is 8. So C, then CD is 5, that is 20. Then DE is 1, that would be 4. Then EF is 4, that would be 16. And then we have a new point, which is C. So I'm going to measure, which is G. So I'm going to measure G from B. And this distance here, I can put it right here. So this, ladies and gentlemen, is G. We need G. So usually drawing the vector diagram, we've been sliding members from here, put them here onto the right of this line. But now, since we are dealing with an overhang reactions, our reactions are in the middle of the framework. They are not at the extreme ends. And ladies and gentlemen, I repeat, this only works for a framework. For a beam, do it the normal way, but for a framework, this is what you do. So instead of sliding these members this side onto the onto the left of this line, you slide and put them onto the right of the same line. So this is our polar diagram line. Instead of sliding these lines this side, you're going to slide them this other side. I hope I make sense. So this is what you do. I'm going to start off by getting B and C, because this is the line B and C, and then I also get K. So B and C, come and get B and C. So I'm saying instead of drawing the lines down here, you're going to draw them onto the right. So B is here, and then C is right here, like that. I hope I make sense. Then I'm going to slide G also. Bring G and put it right here. Then I can also slide D and E. So D and E. So this is D, and then this is E. Now remember we said this A right here is actually down here. So I am having A here and I'm having F here. So you realize that A is also a horizontal line and also F is a horizontal line. So I need to slide a horizontal line to A and F. So at A it's a horizontal line and also F a horizontal line. I hope you see the difference. I'm saying for a normal framework, you're drawing these lines on the left. For an overhang framework like this one, you draw the lines on the right. That's the only difference. Perfect. Now look here. A is meeting B at point H. I'm sure you remember this. So A is meeting B at point H. So this point is H. But at H, we have this line which is meeting C at J. So I'm sliding that line. We're saying at H, there is this line here. And that line is meeting C at J. So this is meeting the line from C at J. So this point here is J. Hope you see that. But at J, we're having this line which is meeting G at K. So I'm going to slide this line which is at J. And we are saying the line from J is meeting the line from G at K. So this line from J is meeting the line from G at point K. I hope I'm making sense. Now that we have that, I can go this other side and say F is meeting E at M. So this line F is meeting E at M. But what is happening at M? There is this line. So slide that line and put it at M. So like this. But we can see that this line here at M is meeting the line from D at L. So it's meeting the line from D at L. So this point is L. But at point L, we can see this line here. But this line is what? Line K, L. I already have point K here. So if I simply join, this line that I draw must be parallel to this line up here. So I'm going to simply join this. And if you're accurate like I am, if I slide this line, you can see that the two are actually parallel. I'm a little off, but you can see that the two are parallel. Perfect. So I outline this. And ladies and gentlemen, for an overhang framework, this is the vector diagram. And you use it in the same way we use the normal vector diagrams we've been drawing. Just that it has a weird shape doesn't mean that use is different. We use it exactly the same way. So that's a vector diagram. Now you use this to determine the magnitude of forces in all these members, and also to determine the nature of members, whether a member is a tie or a strut. So I'm going to simply test with just one joint to show you how this works. So I'm going to pick out this joint. Remember we said you have to draw a fresh diagram down here. I'm not going to do that for purposes of keeping this video short. Perfect. So I'm extracting this joint. So this, and this. So we said you always start with a known force. This is CD, L, K, and J. Perfect. So CD, as you can see on the vector diagram, CD is going down. So CD has given us a direction. We are going clockwise. So CD, go down. Then DL is going down. So I go down here. DL is going down. So I go down. Then LK is going up. So go up. LK is going up. Then KJ is going up. So you go up. And then JC is going down. So you go down. And as you can see, you transfer these back to your stress diagram down here that you've reproduced. Perfect. So in my case, I'm going to put the arrows back onto this, which you're not going to do because you've drawn a fresh stress diagram. So if the arrow is going down, mirror it down, it's going to be going up. Then this is going up, mirror, this is going up, mirror, and this is going down, so mirror. And as you can see, this member usually has been a strut, but in this case it's already a tie. So that's where the difference comes in an overhang beam. So go ahead and determine the nature of members in this framework and determine the magnitude of forces in all these members using the same vector diagram. Thank you for watching. See you in my next video.